how to test a hydraulic pump. Let's say we're going to test it in a test bench, and we're also going to tell you how to test it even if you don't have a test bench. In the actual machine, you can use a test bench, or you can test it right in the same machine in which the pump is going to work. So, but how do you test it? How do you know the pump is good, right? So let's start with the test bench example over here. You have a hydraulic pump. And so you have a flow meter right after the pump. And then you have a relief valve over here on a test bench. Let's say you have a flow meter right after the relief valve on the return line over here. You know, if you have a test bench, you have a test bench with all the goodies to find out everything, right? And so you have over here, you gotta have something to give resistance to the flow. And say we're gonna draw another flow meter over here, so that you know how much flow is going into the other locations. And we're gonna have a gauge, pressure gauge over here. So this is gonna be a variable displacement. It can be a fixed displacement, does not matter. But let's say this is the schematic that we have to test this pump, right? So you have your flow meters, you have your relief valve, you have your needle valve to give pressure, and you have your pump and motor. So let's say this pump is, for reason of this exercise, we're gonna say this pump is a 2.75 cubic inch unit. And so you want to test it. The way to begin the test is basically, if you have a variable displacement pump, to begin with, you gotta put oil in it. You don't want to start the pump dry. If you start it dry, it's just gonna break. So you wanna put oil in the pump before starting it, and then you start the system. Before starting the system, you wanna have the relief valve all the way open and the needle valve all the way open, so there is no resistance in the system over here. So you start the pump with oil in it. If the pump begins to run and it's minimum pressure, and flow just goes through. Some may go through the needle valve, and some may go through the relief valve. And if you have all the monitors in place, all the flow meters and pressures, you can see everything on where the flow is going and everything, right? So you see some flow on the main flow meters, and you see flow on the other two on the return, and you see is minimum pressure in the system. The next step that you want to do, you want to close the needle valve. You close the needle valve, you can close it all the way in. At that moment, there's not going to be any more flow coming through the needle valve. There's nothing in there. All the flow is going to go from the pump through the relief valve, and the relief valve is all the way open. So at minimum pressure, the relief valve is going to be all the way open, and all of this flow goes through the relief valve. No pressure. At that moment, you start closing on the relief valve, and you start recording pressures and flow. So you know that you have 2.75 cubic inches on the pump, and now you're ready to test if this pump is going to give you what it's supposed to give you, right? So what you do now, you start recording what you have. So at 275, let's say you're gonna do it at 1800 RPMs, and you're going to do it at 2400 RPM. In order to have, if you want to do it at more than 1 RPM, your test bench is going to need a motor that is going to be able to change the RPM that the pump runs. So let's say you're going to test it at 1800 RPM. So 275 times 1800, and actually it's not 1800, it's going to be 1750, because it's going to is starting, we start working with efficiency. So 275 times 1750 divided by 231 equals 20.8333 GPM. So this pump over here at 1750 RPM is going to give you 20 GPM. Supposedly, anyway. Supposedly. If we tested at 2400, again, we run into efficiencies of the electric motor. We don't know how efficient the electric motor is. But for reason of this example, we're going to say 275 times, let's just say 2300. Divide by 231 equals 27.3809 GPM. And so you have 20 and you have 27 GPM, right? And now, depending on what RPM you want to test it, you want to start closing the relief valve and start recording flow rates at different pressures. So you have 1000 psi, let's say you have 2000 psi, let's say you have 3000 psi, 4000 psi, and I don't know, maybe 5000 psi, depending on what's the pressure rating of this pump, what's the maximum pressure rating, right? So you want to start increasing the pressure slowly by closing the needle, by closing the relief valve, because now the flow control is closed. There's no way the oil can go anywhere. The only place it can go through is through the relief valve. And you start closing it, and you start closing it, and you start increasing the pressure, and then you start getting numbers over here, and then you put them in, and you get to see if it's going to be 20 GPM. You know, let's say 1800 RPM and 2400, those are not the numbers. Let's say 1750 and 2300, and you're gonna get some numbers over here. You're gonna get some numbers, and those numbers that you're gonna get are never ever going to be the 20 GPM and never ever going to be the 27 GPM. It's never gonna happen, because no pump is 100% efficient. Not even the electric motor is efficient. That's why we derated it from 1800 to 1750, and we derated it from 2400. I just pick a number. I put on 2300 over here. Maybe higher. But the point is that there are efficiencies on those motors, on those electric motors. You might want to know the efficiency of that electric motor to find out what is it supposed to be. So a piston pump, for example, a piston pump may run up to let's pick a number. Let's say in the 95% range. So these numbers over here that you're gonna get at a different pressure rating may be around 95% efficient of the pump, which, depending on the RPM that you're gonna run, you may get 95% of 20 GPM or 95% of 27 GPM. It's going to be around that number, and when you increase the pressure from 1000 to 4000, you may see a small decrease of flow rate on a piston pump. When we're talking about a fixed displacement pump, a gear pump, or a vane pump, the efficiency may go much lower than 95%, might go to 80%. I don't know. I have to look a specific data sheet for each pump because each manufacturer might be different, but I can tell you it's not going to be in the 90s. It's going to be below the 90% for a gear pump and for a vane pump. So when you test it, basically what manufacturers are going to give you, they're going to give you a theoretical displacement of the pump, but in the real world, after you put on efficiencies and everything, it's going to be, piston pumps are going to be maybe in the 95% efficiencies, and the other pumps are going to be much lower than this. So you have to look at what the manufacturer is telling you, and you have to look at the flow rates to make sure the pump is within the range of flow rates that are going to that the manufacturer is going to give you. But this test right here is basically how a lot of manufacturers test their hydraulic pumps. Basically, they put pressure and flow and they record those pressures and flow, and if that recording is within their efficiency, then the pump is good. Now, if you don't have a test bench, the way to do it in the system is just to put the pump in the system, run it, increase the pressure, and see if the pump is running. If you have a flow meter, you can measure the flow. If you don't have a flow meter, the best way is to see the response of the machine, if it's the way it's supposed to be when the system used to run properly. You know, that's the best I can tell you. Maybe measure the speed of the cylinder and figure out how much flow is going through it. But you can do it in the machine just by looking at the machine performance and its speed when you put the pressure, when you increase the pressure. So that's basically how you test a pump. That's how you handle a pump test. And that's the video for today, and we'll see you next time. Thank you much. Bye bye.